All right, here's our next Fast 5 review on more geometry topics. These are going to focus on planar geometry topics. So, beginning of every math test, they give you this reference sheet, this formula sheet, and it doesn't change. So you want to make sure you familiarize yourself with all these volume, area, special right triangle, some little key information pieces down here about triangles and circles. That's not going to change, so make sure you study that before you get going on your test. So, intersecting lines R, S, and T are shown below. They create this lovely triangle picture, and this is a favorite standardized test question. I feel like I see this almost on every single test I've ever seen, something like this. So I see a triangle that pops up, and I just saw on my reference page that triangles add up to 180 degrees. So there's some other properties of intersecting lines we have to remember. Intersecting, well, when you have intersecting lines and you have adjacent pairs, these angles create a supplementary or a 180 degree relationship. So if this is 106, that would be a 74 degree. By the way, this question is on the no calculator part of the test, so no calculator. Triangles have to add up to 180 degrees. So at this point, you could figure out this missing angle here by subtracting these from 180, but then you have to do that same math over here to find his supplement. There's actually another theorem out there in the world called the remote angles theorem. If you take this exterior angle, he's going to be the same thing as the sum of the two remote angles, they call them. So if you just add these two angles together, you're going to get the angle x here. So it's kind of silly. It's like you subtract it from 180 and then you like do the math backwards again. Skip that. All right, so 74 plus 23 is going to be our answer. So without a calculator, 97. And actually, you notice this isn't multiple choice either. So this is one of those gridded response questions where you have to bubble in 97. All right, moving along. Oh, these baby and mama triangles, right? So I see a little baby triangle, 6, 8, and then something. And then the mama triangle is this big one here. All right, so they're similar triangles because of the parallel lines theorems. You don't really have to remember the theorems themselves, but you do have to know they have a proportionality to them. So the baby triangle has a 6, the mama triangle has an 18. Looks to me like their relationship is the mama is triple the baby. So the question that they have is, what is the length of CE? They want to know the hypotenuse of the mama triangle. So we need to figure out this part, or we need to figure out this part. It doesn't really matter. We just need to know something else. So we need to do a little Pythagorean theorem is my point. You know what? I'm thinking I'm going to find this side right here. I'm going to find this hypotenuse of the baby triangle because I think I already know it. Remember Pythagorean theorem, 6 squared plus 8 squared equals c squared. This also happens to be a 3, 4, 5 triangle that's been doubled. So I already know that c is going to be 10, but remember without a calculator I would have to do a little work here. 36 plus 64 equals c squared, so 100 is c squared. The baby hypotenuse is 10. So this guy right here is 10, which means the mama hypotenuse is triple that. So mama hypotenuse is 30. And again, this is gridded response. Without a calculator, we would have had to know all that stuff. Oh man, good news. All right, this on their formula sheet, you had some 30, 60, 90 formulas, I believe, right here, and 45, 45, 90 as well. So re-familiarize yourself with those formulas. Remember, I'm trying to get under 5 minutes, so let's see what I can get through here. I do have a couple of 30, 60, 90s. In fact, I have an equilateral triangle that's split. So this is also a 30-degree angle, and it's equilateral, so that tells me a lot of stuff. They want to know the length of AD. Guys, I think I'm already done. I don't even think I need to do this work. If this is an equilateral triangle, these are all 12s. And if you cut through the angle, that means you cut through the base down here. So these both have to be 6s. I think we're done. AD is 6. I didn't even need my special right triangle formulas there. All right, this one's fun. There is on the formula sheet, a note about circumference, I believe, isn't there? No, maybe not. Oh, right here. Circumference is 2 pi r. True. The other formula you might be familiar with is diameter times pi, because twice the radius is the diameter. So I like diameter pi, but you know, whatever makes you happy. It says the circumference is 36. What is the length of arc AC? Now there's a symbol here. Remember what that symbol means? That means 90 degrees. So if this is 90 degrees, that is a quarter of our circle, right? What we need to figure out is how large the diameter or the radius is. Oh, scrap that. We don't need that because I already know the whole circumference is 36, and if this arc is going to be a fourth of it, I think we just need to divide that by 4. So that arc must be 9 units. Easy peasy lemon squeezy. And that brings us to 5 minutes-ish. All right, I'm going to stop.